Alright, we have this problem that could arise in an Algebra 2 class. So let's solve for x and see what happens. Okay, so let's get a common denominator. So, well, let me repeat the initial line first. So x plus 12 over x minus 3 is equal to 1 plus 4x over x minus 3. Then if I get a common denominator, x times x minus 3 plus 12 all over x minus 3 is equal to x minus 3 plus 4x over x minus 3. Okay, so I can clear out the denominator. If I multiply out by the top, I get x squared minus 3x plus 12. On the other side, I get 5x minus 3. So x squared minus 8x plus 15 equals 0. And so we find that x minus 5 times x minus 3 equals 0. And so that leads me to, apparently to two solutions, that x equals 5 or x equals 3. Now, unfortunately, 3 is clearly an extraneous solution. If I plug 3 into the original equation, I get a divide by 0. So this is extraneous. If I plug in x equals 5, it turns out that one's the real solution. Now, why in the world did this happen? This first step's all right, getting a common denominator. But the second step here is only a one-way implication. If x is equal to 3, then I can't go from the bottom line to the top line. Now, the top line, I can go to the bottom line by multiplying by x minus 3. That's all right. But I can't go from this bottom line to the top line if x is equal to x minus 3. Now, this is an if and only if, and that's an if and only if, and that's an if and only if. But this one is strictly top implies bottom, but bottom does not imply top. So we have shown that if there's a solution, then it's x equals 3 or x equals 5. However, without checking, we can't be sure that either one is a solution. So if there's an answer, it's x equals 3 or x equals 5. That's different than saying that x equals 3 and x equals 5 are answers. So the only way to check is to plug back in. Clearly plugging equals 3, x equals 3 does not work. Plugging x equals 5, it turns out, does work. So this one only has one answer, x equals 5. And the reason is because the reason that x equals 3 doesn't work boils down to this single implication on this step right here.